Let's now consider the computation of the expected value and the standard deviation and the variance for a continuous random variable. So here we have the random variable 6x minus 6x squared. The graph of the PDF is shown here. The total area under this parabola is equal to 1. Now notice that the apex of the parabola is actually bigger than 1. So right here is the y-coordinate 1. It's perfectly okay to have y-coordinates up here that are bigger than 1. What's important is that the total area is equal to 1. So you can't have a probability bigger than 1 because the areas under the curve here are going to be less than 1 because the total area is equal to 1. But it is okay to have the occasional y-coordinate that's bigger than 1 as long as the total area is less than 1. Let's find the mean, the standard deviation, and the variance of x. So first off, we figure out the expected value of x. And the way that we compute this is we integrate over the entire possible values of x, so in this case from 0 to 1. We take 6x minus 6x squared, but I multiply this by x dx. So this kind of parallels what we did with the discrete random variables. We have the probabilities right here, 6x minus 6x squared. I multiply it by the possible value x, and instead of adding up, I integrate from 0 to 1. So I get the integral from 0 to 1 of 6x squared minus 6x cubed. Dx. So doing the integral, we get 2x cubed minus 6 fourths x to the fourth from 1 to 0. Plugging in 1, we get 2 minus 6 fourths. Plugging in 0, we get 0 minus 0. So finally we get 2 minus 6 fourths, which is 1/2. And so the expected value of x which of course is the same thing as the mean, is equal to 1/2. Okay, so that's the expected value of x. Next we figure out the variance or the standard deviation of x. First off, let's get the expected value of x squared. So the next thing we do is figure out the expected value of x squared. Now this will be very similar to the integral we just did. I will integrate from 0 to 1 again. I have the 6x minus 6x squared again. But this time I multiply by x squared in front, dx. So integral from 0 to 1 of 6x cubed minus 6x to the fourth dx. Okay, so we do the integral. We get 6 fourths x to the fourth minus 6 fifths x to the fifth, evaluated between 1 and 0. Plugging in 1, we get 3/2 minus 6 fifths. Plugging in 0, we once again get 0 minus 0. And so we end up with 1/2 minus 6 fifths, which works out to be 3/10. So we'll keep this result up here, that the expected value of x squared works out to be 3/10. Okay, now we're in position to find the variance as well as the standard deviation. The variance of x is going to be equal to, just like before, the expected value of x squared, 3/10, minus the mean of 1/2 squared. So that's going to be 3/10 minus 1/4. And so getting a common denominator of 20, we get 6/20 minus 5/20 makes 1/20. The variance must be positive. If I get a negative number for a variance, I've made a mistake. I must have to do it again because the standard deviation of x will be the square root of the variance. So this will be the square root of the variance, 1/20, or 1/2 times the square root of 5. And this can be found on a calculator or else rationalize the denominator, but that is essentially the answer. 1/2 times the square root of 5 is the standard deviation of this random variable.